Hello everyone, in this video we're going to explore topic 8.9 disk method revolving around the x or y axis. Alright, in the known cross-sections technique you learned in previous lessons, you given a base regions in the plane and you build a solid by stacking up slices perpendicular to an axis. Each slice has a specific known shape like squares, rectangles, triangles, semicircles, etc. Then the volume is found by integrating the area of each cross-section. Now, in the disk method, it's really the same idea, but the cross-sections are specifically circles or the disk right here that come from revolving the regions around an axis. So you look at this one, if you revolve this one around the x-axis, for example, you will get the cylinder right here, right? The radius of each disk comes from the distance from an axis of revolution, which means right here to the curve, right? So the distance from here to here is the radius. The area of each cross section is A of S is pi R of S squared, right? The volume is V equals the integral from A to B of A of S, right? ds. Now you know that the formula for the volume of a cylinder is V equals pi R squared times H, right? So if you look at the figure right here, horizontal axis of revolution, the volume is right here, right? So I'm going to write it over here, V equals pi R squared times H, right? Now when you revolving this one about the x-axis, you get the cylinder right here, right? So in order to calculate the volume of the cylinder, you're going to use this formula, right? The height is W right here, or ds, right? The radius is right here. I have V equals pi, the integral from A to B, the radius squared, right? Times ds. ds actually delta S right here, right? Now, vertical axis of revolution is going to be exactly the same thing, right? It's just in terms of y, right? So when you revolving this one about the y-axis. Now, example number 1, using the disk method, find the volume of the solid formed by revolving the region bounded by the graph of f(s) equals square root of psi s, and the x-axis about the x-axis for s go from 0 to pi. Using the graph of f(s), shade the regions being rotated and draw a representative rectangle. Alright, so the region being rotated is right here, right? And the representative rectangle is going to be something like this. Now, if you revolve this guy about the x-axis, you will get a solid something like this. Alright, so by the formula, you have the volume equals pi, the integral from 0 to pi of square root of psi s squared, right? Because this one actually the radius, right? ds. Then it's going to be pi, the integral from 0 to pi. When you square this one, it's actually psi s ds, right? Now take antiderivative of psi s could be negative cosine s, right? So it could be negative pi cosine s evaluated from 0 to pi, right? Now I need to rewrite negative pi, right? Substitute pi for s, it could be cosine pi, minus substitute 0 for s, it could be cosine 0, right? So I have negative pi, cosine pi equals negative 1, cosine 0 equals 1, so it could be minus 1, right? So the answer is 2 pi, right? Now let's move on to example number 2, revolving around the x-axis. Alright, so y equals negative x plus 1. We need to get this one, right? So x equals 0, y equals 1. It's going to be right here. X equals 1, y equals 0. It's going to be right here, right? So we just connect these 2 points. Alright, so the region should be this one right here. Now we need to revolve this one about the x-axis, right? So the representative rectangle is going to be right here, right? Then this one actually the radius of the solid, right? And the radius is right here, the function y, right? Now if you revolve this one about the x-axis, you will get the solid something like this. So volume equals, now we need to find the lower bound and upper bound. The lower bound is 0 right here, upper bound is 1 right here, obviously, right? In order to find this one, we just set up this one right here, y equals negative x plus 1, right? And y equals 0. The x-axis right here is y equals 0, right? We just solve a system of equations right here to get x value, right? So does that mean we need to equate this one right here, right? So I have negative x plus 1 equals 0, and then x equals 1. That's why we have this one right here, right? So the volume is pi, the integral from 0 to 1 of this one right here, square, right? And dx, which is the height, right? Now I just rewrite this one a little bit. It's going to be pi, the integral from 0 to 1 of 1 minus s altogether square ds. Then I'm going to use the complete square formula. It's going to be a minus b altogether square equals a square minus 2ab plus b squared, right? So this guy turns out to be pi times the integral from 0 to 1 of 1 minus 2s plus s squared ds, right? Then I'm going to take anti-derivative of this one. It's going to be s minus s squared plus 1/3 s. Then I need to evaluate from 0 to 1, right? So it's going to be pi times, substitute 1 for s, it's going to be 1 minus 1 plus 1/3. Substitute 0 for s, it could be 0. The answer is pi over 3, right? Now let's move on to this question. Y equals square root of s from 1 to 4, right? Now s equals 0, y equals 0. We get the first point, right? S equals 1, y equals 1. Second point, right? S equals 4, y equals 2. Right here. Right? Now I just connect these 3 points. Now we have restricted domain from 1 to 4, right? So 1 right here and 4 right here, right? So the region should be from here to here only, right? Now I need to get the representative rectangle. So it's going to be something like this. And this guy is actually the radius, right? And this one is delta s, right? Now, if you revolve this one about the x-axis, you will get the solid something like this. So v equals the integral from 1 to 4, right? Pi put in the front. Now this guy actually radius in terms of s, right? So I have square root of s altogether square, right, times ds. Right, so this guy turns out to be pi times the integral from 1 to 4 of s ds. Now take anti-derivative of this one. It's going to be pi times 1/2 s square evaluated from 1 to 4, right? So it's going to be pi over 2 times. Substitute 4 for s, it's going to be 16. Substitute 1 for s, it's going to be 1. Subtract 1, right? So the answer is 15 pi over 2. Now let's move on to example number 3. Revolving around the y-axis. The function y equals s squared from 0 to 4, right? Now s equals 0, y equals 0. We get this one. S equals 1, y equals 1. S equals 2, y equals 4. So it could be like this, right? So if you connect these 3 points, it could be something like this. So the region should be from here to here. Now we need to get a representative rectangle. So it could be something like this. Alright, this one actually the radius are in terms of y, right? And this one is delta y, right? The lower bound is 0, the upper bound is 4, right? Now if you revolve in this one about the y-axis, you will get something like this. So we have volume equals pi, the integral from 0 to 4 r. So we need to rewrite this one in terms of y, right? So I have y equals s squared. Does that mean s squared equals y, right? So then I'm going to take square root both sides. It's going to be s equals plus and minus square root of y, right? Now observe that this region is above the axis from 0 to 4, right? So s should be positive, right? So we only pick s equals square root of y, right? So we put it over here, square root of y right here, all together, square dy, right? Alright, so this guy turns out to be pi, the integral from 0 to 4 y dy, right? Now, take antiderivative of this one, it's going to be pi times 1/2 y squared, evaluated from 0 to 4, right? So this guy turns out to be pi over 2 times. Substitute 4 for y is going to be 4 squared. Substitute 0 for y is going to be 0, right? So the answer is 8 pi. Now let's move on to this question. Y equals s power 2/3. Now I convert this one to radical. So it's actually cube root of s squared, right? So now s equals 0, y equals 0, s equals 1, y equals 1, right? S equals 2, y equals cube root of 4, right? It's going to be something like this. So I need to rewrite s in terms of y, right? So I have s power of 2/3 equals y. Now to remove this one, I need to raise to the power of 3.5 both sides, like this. Right? So this guy cancel out, this guy cancel out. So I have s equals y power 3.5, right? So the region should be this one right here. Then the representative rectangle should be this one. This one actually delta y. This one actually the radius in terms of y. And the radius in terms of y is right here. Right? Now if you revolve in this one about the y-axis, you will get something like this. So the volume should be pi times the integral from 0 to 1 right here. 0, 1, right? Of this guy right here, right? Y power 3.5 all together square dy, right? So this guy turns out to be pi times the integral from 0 to 1, 2 and 2 cancel out, so it will be y power 3 dy. Take antiderivative of this one is going to be pi times 1 over 4 y power 4 evaluated from 0 to 1, right? So it's going to be pi over 4 times Substitute 1 for y is to be 1 power 4 minus substitute 0 for y is to be 0 power 4, right? So the answer is pi over 4, right? And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in